My belief is that there are four of the types of energy that we use that are available to us on this planet. There are four different essential types of them, all of which come from the Big Bang in four different ways. And that's what I figured I would do is I would say everybody should know this. This is cool. This is the stuff that I wish every single human being were curious enough about. So in other words, where did this oil come from? What is photovoltaics? What's all this about? And essentially it all comes from the Big Bang, four different ways. So about 14 billion years ago, there was no universe, and all of the matter and energy and stuff that was to become the universe was in an infinitesimally small place that, for one reason or another, nobody understands this, nobody ever will, as far as I'm aware, it exploded. Okay? And it's been exploding and expanding ever since in the form of, galaxies and novas and black holes and so forth and so on. Nuclear energy, what we do now for nuclear energy on this planet, and as you know, this encompasses, in the teens in terms of percentage of energy in the United States, but it's 70 or 80% of France's energy. It's a big deal in certain parts of the world. And of course, it's regarded rightfully as very dangerous. We wish we didn't have to do it, but we seem to be doing it anyway. So, what is nuclear energy? It is essentially fission. It's the breaking apart of complicated atoms. So, very shortly after the Big Bang, where there were very, very simple atoms, these began to coalesce in something called nucleosynthesis into bigger atoms, some of which, for instance, uranium, winds up on the planet Earth. We wind up with some uranium. We find it, and here we are 4 billion years later, breaking it apart and exacting enormous amounts of energy from the process that essentially Einstein discovered in the theory of special relativity, E equals mc squared. So a little bit of mass becomes an enormous amount of energy. So when you break that complicated atom apart, you wind up with slightly less mass than you started with, and you can, on a good day, you can harness that energy and do good things with it. There are operational issues that we've seen in, for instance, Chernobyl and Fukushima. There are the issues of disposal of nuclear waste, Yucca Mountain being the most controversial and kind of current issue. In other words, what are we going to do with this stuff whose half-life is 500,000 years? In other words, you make a decision to put up a nuclear reactor, you're making a decision whose impacts are going to last at least 500,000 years. That's a big decision. So what else happened at the Big Bang? Well, we put into place the mechanism by which galaxies would be formed. From those galaxies became our solar system. From our solar system became our Earth. About 4.54 billion years ago, our Earth was formed. So, and since that time, so here you have 4.5 billion years during which the sun has been traveling across, the sun's radiation has been traveling across those 93 million miles, hitting the Earth. Fairly recently, what's been happening? So we have 8 minutes ago, the photons left the sun that we can harvest right now in terms of photovoltaics. Yesterday, it warmed up a part of the Earth, warmed up a part of the ocean. We can extract that energy in the form of wind or ocean current. Okay? So 100 years ago, that sun's energy became a tree that we can now chop down and burn or do other types of energy extraction processes with. We don't have to combust it. We do pelletization and torrefaction and pyrolysis and gasification. So there are other biomass technologies. But my point is that almost all of these renewable energy technologies came from the fact that the Earth was formed in the solar system, in this rare thing where we're orbiting this star 93 million miles from us, and every day we receive 6,000 times more energy than all 7 billion of us use. This relationship between the sun and the Earth. So most of these things have to do with the fact that every minute we're receiving 6,000 times more energy from the sun than we're using. Okay? So that energy can be harvested in the form of photovoltaics. It can be harvested in the form of wind, concentrated solar power or solar thermal, in other words, concentrating the sun's rays on a certain point or a line and using that heat energy. Ocean thermal, the fact that the oceans are heated at different depths, you have different temperatures. Ocean current, the reason these oceans are flowing is because of the way in which the sun heats up the surface of the water, and the earth is, of course, rotating. So those are the basic issues there. There's also another one, the fact that people don't, I think, all the time understand that another thing that happened when the Earth was formed was the fact that it became very hot. Simply the fact that the way in which it was formed, in other words, out of the compaction of gases, but also gases and then, of course, various solids came. So here you have all of a sudden this sphere, 8,000 miles across. Now all of a sudden you've got liquid metals, liquid nickel and iron, that are now making their way to the core of the Earth. All the friction of that actual liquid making its way to the core of the Earth, and the fact that some of these things are radioactive. So there are 3 or 4 different things that give rise to the heat that's within the core of the Earth that we can extract in the form of geothermal. The other thing, of course, is the tidal energy that comes from the fact that the moon is revolving around the Earth. So, and the moon, as you may know, was, at least the modern theory of this thing, that was formed from a fantastic explosion and impact into the Earth a few tens of millions of years after the Earth was formed. Huge impact, out comes this thing we call the moon. So here it's traveling around the Earth, moving the Earth's tides and creating an enormous amount of energy in terms of that flowing water. So we can extract that in terms of tidal. So those are other things that are directly related to the Big Bang. No Big Bang, no tidal energy. What happened shortly after the Earth was formed is life. We had life actually within 500 million years. So imagine 4.54 billion years ago the Earth is formed. Imagine that 4 billion years ago all of a sudden there's microscopic life here. So fairly soon after the Earth was formed. Over that period of time, so here it is over a period of 4 billion years, think of all the life forms, initially obviously microscopic, but later plant, later animal, living for hundreds of millions of years over long periods of time, living and dying, which is essentially the sun's energy. So in other words, the reason those are alive, were alive at the time, is simply because of the sun's energy. So there, for instance, animals eat plants and plants photosynthesize. So all of that chemical energy stored in that tissue is ultimately solar energy. Having said that, it's fossil fuels. In other words, it's believed to be, anyway, the result of the fact of all of that biomass living over all of that time. So what we're doing in a very short period of time, in the last 150 years, we've extracted most of the easy, inexpensive fossil fuels, certainly oil, from the Earth. So in the blink of an eye, we've extracted most of the energy that took billions of years to accumulate. That's why people are so frantic about this.